So we saw how to read data from a Hive table, flat files, JSON files, and Parquet files, right? And we perform basic operations like group by, filtering, and joins we have seen. And with respect to RDD, yeah, how to create this RDD using SC.text file. And when you are creating data frame is something that is an extension to the RDD, where we will have rows and column notation in representing the data. And we know that Catalyst Optimizer will work in data frame to improve the performance. So where RDD is not having that. And we also see in RDD is a kind of immutable thing where you have to derive it every time a new RDD. You cannot modify the data, and also we know DAG works here. Lineage will be taken care with the help of DAG, directed acyclic graph. So where each and every stage, so it remembers the operations. So whenever an RDD, whenever an node fails, it automatically recovers because Spark remembers everything. So this is all what we discussed about Spark. And now today we will see a few other concepts in Spark. So first thing I would like to go with repartitioning. So repartitioning in a sense, we'll see how many ways are available to deal with repartition. So repartition is something that, say for example, when you're reading the data, and it's purely depends on how many blocks are available in your HDFS location. We know that Spark is using the HDFS storage level, right? So say for example, it has, by default it will create 2 partitions, but if it has more than that, it will also create those many partitions. Now to improve the parallelism, say for example, there are 6 partitions are available, and you wanted to make use of all nodes, and you wanted to increase the partitions, you can do that. All, you know that data is very less, no need to no need to utilize all nodes, but you need to reduce partitions. So you can again reduce the number of partitions also. So that's how we have 2 options. One is to increase, one is to decrease. So let's see first by reading one sample file. Okay, it's not here. Yeah, so I'm going to read the text file like this using a sc.text file. So now see here, I've given the RDD name. Well, RDD name is RDD_NYSC equal to sc.text file. So this particular text file will read the data from a specified location and then creates the RDD. But if you see here, after file, I have given comma 4. So 4 means 4 partitions. I would like to create 4 partitions. Otherwise, by default, 2 partitions. Okay. So now when I execute this, yeah, the RDD has been created. Now I want to know on each partition how many lines of data is available. So we know the code, and this is what RDD_NYSC dot map partitions. So map partitions is another method, so which will display number of lines on each partition. So now, so 0th partition, first partition, second, third. So total, it has divided almost equally, but not exactly, right? So now we have 4 partitions. So there is a method called repartition. So using repartition, you can either decrease or increase. And coalesce, there is another one function coalesce where you can only increase it. I think let's see first by, I will use the same command to create one more RDD with one. Okay, I'm creating two RDDs. One is with RDD NYSE and other one is with RDD NYSE1. Same syntax, and I'm creating 4 partitions. You can also check this also, like it will create almost same number of lines on each partition. Okay, so now let's try to repartition. I mean, let's try to increase the number of partitions. So what you need to do is just RDD, you type RDD NYSE dot repartition. Just type repartition and then hit the tab. Yeah, repartition. So here 4 partitions are available. I would like to increase. So I will give 6. And when you are creating like this, you have to assign it to a new RDD, right? So RDD new RDD NYSE. So now I'm increasing the number of partitions. So repartition is one concept. It will be used to either decrease or increase. And repartition concept is it evenly distributes into all partitions. You got it, which means, say for example, you have some 4 nodes and you are splitting into 6. So now the data will be divided by whatever the total count available in this particular file divided by 6 and will split into 3 nodes. So now let's increase it to 6. Say for example, we have 6 nodes, and how it will be distributed. So it will distributed into equal partitions. Let's execute this, and then we know how to check the number of partitions, right? And not number of partitions, number of lines on each partition. New RDD NYSE. Let's see. Now you see almost equivalent. 6566, 6566, 6465. Earlier it were 4 partitions, and on each partition we had around 14k records on each partition, but now we increase number of partitions, and if you see 9k records, almost 65 66, just one record difference. So it distributed evenly. That is the concept of repartition. So now you can also decrease it into 3. So let's say now same partition I will try to use 1, because now it is not and this particular new underscore RDD NYC is having 6 partitions, but the original one, you see, original one still it must be having 4 partitions. All right, so now let's reduce it into 3 partitions. Okay, I'm taking the same RDD NYSE and then repartition of 3, and I'm assigning it to the same partition. Yeah. Yeah, now see again almost evenly distributed. So it repartitioned from 4 to 3 now. Earlier 4 to 6 we increased, and now it is 4 to 3. So that's how you can decrease or increase, I mean reduce or increase the number of partitions. So this will be helpful to improve the parallelism. Say for example, that is what the case. You have 8 node cluster, and only 3 partitions are available and 3 partitions are working on 3 nodes, and your data is huge and you wanted to split the number of partitions across all the nodes to make use. So you can increase the partitions. At the same time, if you feel that the data is very less and you don't want to consume or you don't want to make use of all machines or all nodes, you can decrease the number of partitions. So that's how it works. So this is the concept, repartition. Now there is one more concept is available, coalesce. Coalesce is only used to reduce it. So the difference between coalesce and repartition is, so we know repartition will evenly distributes, but coalesce, if it's not like that, it will not follow any rule. So it will not evenly distribute. It just adjusts the data and it avoids the shuffles, but which means it will make use of existing RDDs only. Sorry, existing partitions only. Say for example, I'll explain how it will work. Say for example, you have partition 1, 2, 3, 4 like this, and you have some data 0, 1, 2, 1, 2, 3, 4, 6, 7, 7, 8, 9. So when you are using coalesce, what will happen? It will not create any new partitions. It will not create any new partitions. It just make use of existing partition and adjust the data. For example, so when you are applying coalesce in these partitions, 4 partitions, so the data will be like this. I mean, it will add the set 4, 6, 7 into a first RDD and 7, 8, 9 into second RDD. So this will be the new partition concepts, which means when you are trying to reduce it, it makes use of existing RDDs only. I mean, existing partitions only. It won't create any new partitions. Whereas repartition, the name itself saying that repartitioning. So it will create new partitions in order to shuffle the data. That's all. So coalesce is used to reduce number of partitions. We will see. Same thing. You can use.
Even like hello, hi Raja. So
yes.
Even like repartitioning, if we want to reduce also, it will create new partitions and delete the old partitions.
Correct.
Okay. And coalesce will
only
increase.
no, reduce, only to reduce the partitions.
Okay.
Okay, so now I'm going to use coalesce function, but I'm trying to use it in RDD NYSC1. So we know that RDD NYSC1 is also having same number of partitions, which is 4. So let's run this. Yeah, I'll make use of this new RDD underscore NYSC1. Yeah. Now you see it is not evenly distributed. I mean, there is huge difference. Okay, so that is the concept of coalesce. But it reduced the number of partitions, but it is not evenly, and it made use of existing partitions only. It adjusted the data from one partition to other partition. It will not create any new partition. So that is the concept of repartitioning in Spark. So any doubts, guys? Kalpana and
No,
Jagan.
no.
Raja, small doubt, Raja.
Yes.
So,
Yeah.
repartitioning, the last one which you said, what is that?
Coalescive. That is another one. Coalescive function. Same. So we have two methods. Yeah.
My question here it is already the partition is happening, right?
Yes. Yes.
So there is no difference between this coalesce and the partition which is already run, right? Why we will do it again?
That's why. So having fewer partitions or having more partitions, it's not a good practice. So why we are suggesting here? Say by default it created 2 partition only, right, Kalpana? So now you have 8 node cluster and 2 partitions may be available on 2 nodes only. So now say for example, you wanted to do it faster and you don't want to consume only 2 machines because other machines are also available. So now when you increase the number of partitions, the data may get splitted into each node, and then you will achieve the parallelism.
Okay. Okay.
And sometimes you also have a some case your data is very less, and you don't want to make use of other machines because some other users also may launch their applications to run their processing data. So you can reduce the number of partitions also. So each partition is having just 100 MB, 100 MB, 100 MB. You are processing 100 MB data on each node. So why to process that? You can just bring it up into two nodes, and then you can start processing, because 100 MB is not a matter, right? So like that. So
Yeah.
just to make use effectively your uh, nodes, so
Okay.
you can repartition the data. Yes, of course partition will be created
So
automatically, but you still can.
repartitioning, it is like equally it is distributed, right? And Coalesce is not in that way. So which one it is the best practice, like using
Exactly.
repartition
So
or
it
Coalesce?
will yeah, there is no thumb rule that you have to go with this only, like repartition or coalesce. Both performs well. That's what we have to understand the concept. So one thing is, when you are using repartition, it will definitely creates new partitions, right? Where shuffles will be more, which means physically it has to transfer the data, which means it will consume time. But again, I can support this because it evenly distributes the data, so that what will happen, all nodes will get the data equally. So that way this is good, which is repartitioning. And coalescing is something that if you are not caring about how the data is being distributed, coalescing is faster, because shuffles will be very less, because it organizes the same existing partitions. It will not create any new partitions. So that way coalesce is faster.
Oh, so when you say shuffles means you mean to say in Coalesce the same data uh, will be in one partition, is that
Yeah,
what you mean to
exactly.
say?
So same partition means, like if you have partition 0, 1, 2, 3. So any of you are trying to now convert into two partitions. So what will happen? So the same partitions will be used. No new partition concept. Got it, Kalpana?
I mean,
Kalpana, you there?
I didn't get that part. New partitions. If we are giving you have two partitions. Now you are saying three partitions. That means one partition needs to be created, right? New partition.
Yeah, but you cannot create using coalesce. Coalesce is only used to reduce the number of partitions.
Reduce the number of partitions.
Yeah,
So we'll use the existing partitions itself. That is
exactly.
what you are
Correct.
saying. So for repartition, it will create the
New
new
partitions.
partition.
Correct.
So, oh, okay, fine. So in repartition also we can reduce it, right?
Yes,
No,
yes,
we
yes.
can only
Both way.
increase it.
Yes, yes, both
Oh,
way.
we can reduce it. So in
Yes.
that case also it will recreate the partition instead of
Exactly.
using the
Exactly.
existing one.
Exactly.
Oh, okay, okay,
Okay. So that is the concept of repartitioning in Spark.
okay,
So now
okay.
we will see persistence. So persistence is something that you can store a data of a particular RDD, or else I can say this way: you can store the data of a particular RDD in cache in order to avoid execution of this particular RDD every time. What does it mean? So let me try to read the data again using this command. Okay, and I will also launch this. Um, okay, so now if you see here, okay, we have performed so many collect operations. That's why we can see this one. And time is 6:23, right? Yeah, 6:23. We performed this operation. So now let's say I executed this already. Yeah, 4 partitions created. Now you see here, I'll go to the storage tab and I see nothing, right? So now once I create this RDD, in subsequent steps, I may use collect operation, I may use count operation, I may use any other operations which will, I can perform any action. So basically we have transformations in action, right? So every time you perform an action or whenever you wanted to require this particular RD to be called, it will execute. Every time it will execute. So for example, in the next line, you are trying to use the count operation. It will execute. The same RDD will execute. We know that lazy evaluation. And sometime you are trying to collect the data. Again, it will execute the same RDD operation. So this particular statement will be executed again and again. Now to avoid it and you want to store the particular RDD execution and then data into memory. So we have persistence concept. So you can just specify RDD NYSE1. Let's say I will use dot collect without caching it. Okay, just execute this. It will show the data, of course. Now you go here. Sorry, I'm sorry, not here. Here, and we'll go to the jobs, and we just collected this information. Now you can see 631 we have collected. This is the 631 time. So if you open this, and if you see here text file, you have text file, and then this is the text file, and then you are using, let's DAG visualization will go again, one more click, it will be clear here. Now you see you are reading the file, yep, and collecting. So this is what it says, file home console.txt. It has to show collect, maybe collect operations. Text file is available on this stage 7. Let me call it again. Yeah, displayed. Make performed, it is displaying jobs. Again, it performed at 32. DAG visualization. Let's click on this one. DAG visualization again. It's supposed to be collect operation. So we are reading the data and then we're displaying the data, but it should show collect. Let's see. So now I wanted to store it into cache. So you just have to specify cache like this. So now what you are trying to hint is this particular RDD, we perform the operation here, right? So now if you use count now rather than collect, if you use count, again that particular statement will get executed. So now we will avoid that by using cache. So when you use RDD name.cache, so now this particular RDD will go and save it into memory. Now you see here storage, it was nothing before, right? Now let's see. Is it the same thing? Something wrong with this? How come his spell is correct only? Cache. Yeah, this is Okay. Mhm. Something wrong. It should show here inside the storage. It will specify that it is reading from a in memory. But I think it's not displaying here. Moment. Okay, let me close this and then relaunch it again. Okay, let me execute it again. Mhm. Okay, so actually I supposed to display the data here. I was getting it, but now so for some reason I'm not able to visualize. But the concept of this particular persistence is so to avoid the execution of a particular RDD operation again and again. So we will use this cache concept. So that's what we will call as a persistence. So this is one method. So cache means by default it will store inside memory only. It stores the data inside memory only. And if you wanted to specify any storage level, it also supports the storage levels like memory only serialization, memory and disk, which means the data will be stored in memory, but if the size is huge, then it will automatically store into a disk. So that's what the concept of memory and disk serialization and disk only. So you don't need to store it in the memory. You wanted to store entire the information on the disk also, it can store. So this is the syntax that you need to use. First you need to import the storage level. If you want to
What will be the default storage level?
yeah, default, if you use cache, it will go to the default memory only. So which is equivalent to storage level that memory only persist. You will use cache here, but you will use persist over here like this storage level that memory only. So default is memory only. If at all you wanted to specify other levels, you can specify like this. First you need to import this, and
If not, we don't specify cache. Can you just send me
if you are
again?
not yeah, if you are not specifying cache, you can use this dot persist and then storage level dot.
I don't use any of this. Like, where will my data be?
So inside cache only, I mean inside memory only. If you're not using anything,
Okay, so if I use like cache, the default is memory only.
memory
If I
only.
don't, it's also memory only. So
Yes,
like,
yes.
what is the case in using this memory only thing explicitly?
No, 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 no. I'll tell you that. By default, it won't store any cache. That's what RDD, whenever you're performing when you're creating an RDD and you're calling it multiple times, like you're performing actions on actions multiple times. So every time you do an action, the same RDD will get executed. The data will not store anywhere unless you save it. You cache it.
Okay.
So if at all you particularly wanted to cache a RDD output, and then you want whenever you are calling again and again, because this particular use case is available in iterative machine learning, you are running some application iteratively. Then in that case, no need to execute any particular RDDs every time. You just wanted to save it in a cache.
Okay.
Okay, so now to specify any other memory only options and disk only operations, any other options, you can specify dot persist. So cache and persist, these two are methods used to cache your data. So by default, if you use cache, it makes use of memory only. And if you use persist, yeah, you see here the same operations, but you can specify storage level dot other options also.
Okay, so normally what we think is like when we collect or do a show or something, it is actually limited to the R session itself,
Yes,
right?
yes.
So if we do a cache,
Mm-hmm.
is the scope out of the session, or its scope is also inside the session? Like
Inside the session itself.
okay, even if we do the cache also, it is inside the
Yes,
session.
correct. But the data will not be stored when you are performing regular operations. You are creating one RDD and you are using collect method to display the data, right? It will just execute that particular RDD and then gets the output and then display it to you. That's all. Now, in the next time, after some few lines of code, you wanted to call it same RDD. Again, it will execute the RDD. This operation. So basically, you
We
have
are
a
just saving the pain and time of the hardware.
exactly to save the time, just to save the time and also cost, right? Every time if you are calling, it will be
Yeah.
waste of resources. So this particular line, it will be executed again and again, and you wanted to avoid it. You can store the information, this particular information, in some cache. So whenever you are calling, so it will not execute the entire statement. It will only pick up the data from here. So that is the concept.
Okay.
Yeah, Kalpana, you have any questions?
No, Raja.
Clear?
Yeah.
Yeah. Okay. I'm disconnecting, so we'll join back just in 1 minute.
Okay.